For those of you that have just joined us, we have a poll question that is on the screen in a little pop-up box. If you want to answer that, our presenter will actually reveal the answer during his presentation. Thanks so much. All right, it is noon Arizona time. Maisha, would you show the results of the poll for me, please? Awesome. So looks like 36% of you said that 5.9 GHz was the commonly called recently made FCC ruling on frequency spectrum for vehicle safety communications. 29% of you said DSRC, and 36% said the safety band. Matt will actually give the answer to this, what the correct name is, what is commonly called, in his presentation. And with that, let's get started. So just thank you guys all for joining. I want to let you guys know we are recording this video on this presentation, and the video will be posted on the ASCE Arizona section website, and the link will be in the Phoenix announcement blast that goes out to everybody. I want to extend a thank you to Y2K and Young Kaprowski for hosting the virtual event on their Zoom software. Thank you to you guys. A couple of upcoming events and announcements I wanted to reach out to you guys on. January 15th is the deadline for the Project and Government Engineer of the Year awards for the Phoenix branch. So if you're interested in submitting a nomination for either a small project, which is under $10 million, or a large project, which is over $10 million, or a government engineer for the Phoenix branch, those are due on the 15th. There was a news blast that went out earlier today with the applications listed in there. And keep in mind the winners for those also go on to the next level of ASCE to also be nominated for further awards. On January 25th is the due date for sustainability public comment. ASCE National is putting together a standard requirement for sustainable infrastructure, which is ASCE COS 73XX. And they are currently opening that standard up for comment. So if you want to do that, there is a link in the last newsletter that went out. Otherwise, you can go onto the ASCE website, and there is a location where you can comment on that standard before it's published. On February 10th, we are having another lunch with the branch that will be virtual, and there'll be more information coming out on that. And then on February 23rd, we're having a utility engineering and surveying seminar that will be virtual, and there's a little bit of information in the news blast that went out about that. Wanted to let you guys know there is a legislation that is currently out in Arizona, legislation SB 1062, that is potentially going to change the way that engineering is referenced and effectively it'll allow unlicensed people to practice at the same level as registered professional engineers. There is a link that I think Maisha can put into the chat box for you guys, if you want to reach out and contact your state senator to reject this bill. That's the position ASCE is taking on it. That is going to be heard today at 2 p.m. So it's very, very urgent matter right now. After this webinar is finished, we will be handing out PDHs to those in attendance. So look out for an email a couple of days from now with that PDH in it. If you want to be a sponsor for the 2021 year, please contact any officer in the Phoenix branch. Your logo and website will be linked to all of our news pages, as well as on the ASCE website and all of our events. With that, I want to get some housekeeping items out. If you guys have any questions, please type them in the Q&A box function. We'll be saving those to the end of the presentation, so that way Matthew can go through and answer them. If there's anything that you want to just say hi or anything like that, that goes in the chat function, but please put the questions in the Q&A section. Like I said before, this is going to be recorded, so it'll be posted on the ASCE Arizona section website. With that, I want to introduce our presenter, Matthew Janak, on innovations in mobility. Matthew has a BSCE and MS in transportation engineering at Michigan State University. He's a registered professional engineer in the state of Michigan and very wide amount of experience in the transportation field, as well as an innovation service lead and senior project manager at HNTB. With that, I will turn it over to Matthew.
Thanks, Stephanie. Just confirm you can hear me all right?
Yes, I can hear you.
All right. Get screen share going. Good afternoon, everyone. Thank you for having me. I know it's well, it's been a long 2020. Now it's 2021. So glad that I can join you from a distance for this. Otherwise, probably would never connect with you all. So my intent today is to go through what presentation here I call innovations in mobility. And starts out kind of touching on what we do today to address mobility. And by that, we're talking about moving people, goods, and services, not just moving cars down the road. And, that's certainly a focus nowadays especially for those in transportation. It's more than just individual people or cars that we care about on the road, or at least we ought to be. So we'll talk about some of the traditional solutions, what we do today, and then introduce and talk about kind of the different innovations and what's up and coming in autonomous connected vehicles, electrification, things like that. I'm a very technical oriented person, so I'll try to keep this at a pretty high level as I flip through the slides, but certainly using the Q&A function if you have questions as I go through, or or certainly at the end for a discussion, I'll leave time to take a deeper dive into any particular area, but I'll try to not get too super technical, especially knowing that we have probably a broad group of people here outside of even just transportation. So I will, if anything doesn't make sense or I'm using acronyms or terms, certainly ask away. I intend to have a good discussion and not just try to put anyone to sleep. So I think already introduced, so I will skip right over that, and I'll talk about Innovation Council a little bit later. So we'll jump right into it. So getting to the beginning of what I was introducing here, what does mobility mean? So nowadays, when we're talking mobility, we're looking to improve the efficiency of the whole network. So it's not just vehicles, it's moving more people. So that, of course, if you look at transit, is one way that you can move more people with one vehicle. So also it's incorporating technology, incorporating freight. Most everyone I know loves their Amazon Prime and second day delivery and everything. Well, that takes a huge network of logistics to get that from point A to point B, and that is also mobility we can be concerned with. So there's also, an equity component to mobility as well. There are people, that have no problem getting in their own personal car and going to work, but there's also transportation disadvantaged, either economically or physically. And there's younger, older drivers. There's, a lot of different aspects to the equity across the mobility system. So what we really are looking to do when we're talking about mobility, increasing mobility is for that wide range. I wanted to put that definition up. So we'll go through here kind of what traditional tools we have to improve mobility. So these are things that if you work in transportation, traffic engineering, ITS even, where I come from now, things that you've been doing. So traditional things are increasing system capacity, of course, intelligent transportation system, using technology to more efficiently use the road. Transit and rail, you can move more people or goods with less vehicles or less space. Terminals for freight, air travel, multimodal solutions. Tolling, of course, can help with mobility as it can adjust the demand on the road. And then traffic demand programs like active traffic management, where you can actually have individual lane control or open up an extra lane certain times of day or reversible lanes. So flying through these here, what we mean by increased capacity, traditional ways we do that, we build more roads, build new bridges, tunnels, expand roads, build new airports, expand them. That is great, and that certainly can lead to and add mobility, but there's a huge cost, and it's also, we're running out of space. In a lot of cases, there's not room to add just more lanes of highway on. Intelligent transportation systems, near and dear to my heart, kind of where I've worked for the past 15 years, is applying technology to transportation, and some of those traditional tools that most everyone is familiar with as being a motorist and a citizen is dynamic message signs and the closed circuit TV cameras, just for you to see what's going on, or you see on the news stations. Then of course they're now everywhere. There's both in ground sensors as well as using cell phone data and things, ways to sensor and monitor traffic, so you can get all those speed maps and pull up on your phone real easily if it's red, green, yellow, and all of that. So all of these go into ITS systems, and of course those help increase mobility. Transit and rail solutions, some of the kind of hot topics now are transit signal priority and bus rapid transit. Both of those are ways of using the technology or using the signal system to more rapidly move the transit buses or give them a priority along the corridors. And then of course, in certain areas or around more population dense areas, light rail and commuter rail systems, and automated people movers that's typically what we call what you see in like an airport, where there's a shuttle maybe that goes between terminals that doesn't necessarily have a driver, but it's on a set track. So that is technically an automated vehicle, but it's not quite what we're on the verge of being on the roads today. And actually a lot of demos are happening around Arizona, which is pretty exciting for you guys, more so than in Michigan and Detroit, which is the Motor City, surprisingly. I think the weather down there leads to better conditions to year-round test. Terminals and stations, kind of talked about that, intermodal connections, and tolling solutions, of course, can help increase mobility. Now there's a price, but tolling solutions can help adjust the demand or expand options for those, so that their other more traditional options or the arterials aren't as congested. And then traffic demand management, and I'll flip right into transportation system management and operation. So this is kind of the newest area in traffic engineering, and that there's been a lot of focus. Most agencies and departments have a TISMO department or have organized around some way. That's the acronym for Transportation System Management and Operations, kind of looking at the whole system together, not looking at just a road, just a bridge, and just the utilities that go underneath it, but looking at the entire system together. So that is kind of the in a nutshell, what we've been up to for the last at least 15 years that I've been involved in the industry and in transportation and in traffic engineering and the different tool sets we have. Now, and what I'll focus of today is we're on the cusp, and really we're right there of a huge disruptive transformation in transportation and in all of our worlds, which we've dubbed ACEs. And so that's automation, connectivity, electrification, and sharing. So that's just a catchy little term that we came up with when trying to present and spread the word here. But they so these ACEs are at the core of the new mobility paradigm. This is between these four concepts is really what is transforming in front of our eyes how we deal with transportation. So first up are autonomous vehicles or automated vehicles and automation. So there are, and I have a series of topics for each one of these ACEs. So starting out with automated vehicle, business cases, there's, as one can imagine, there are across between moving people, moving goods, and everywhere in between. I mentioned airports and the automated people mover type of systems they have there. There are business cases everywhere for automation within transportation. So some of those are last mile and close-in services where shared use vehicles make sense because the high cost can be spread over more users or more time, or things like truck platooning, which you can see in the corner here in the picture, where you can have a series of trucks all under control and be able to go down the road with closer spacing and even share drivers. So for instance, a platoon of trucks one day will be able to cross the country without necessarily having to stop, except for maybe fuel, but not to stop for driver rest time and hours of service, because you're able to shift around and keep them moving through connecting them together. So ride-hailing services, as most everyone are probably familiar with nowadays, going beyond just the traditional taxis, are a huge business case for automated vehicles. So I mentioned, there are several different demos and things going around. I'm not, I don't know what in particular is in the Phoenix area specifically, but I know Waymo and several other companies have been doing a lot of testing around and mapping out in the down in Arizona. So that now Uber did just decide to kind of de-emphasize automation, and they sold off that side of their company to another venture. However, it's not to say Uber and the major transportation network companies like that are shying away from it. They're just realizing that their focus still needs to be on the service they provide, and the vehicles, the automation, that is can be someone else. So ride-hailing services are one of the first business cases that we're seeing autonomous vehicles and automated functions being a real use. First and last mile services, and so that is oftentimes shuttle services of downtown central business district areas, as well as for employees, employee shuttles from parking areas into a downtown and vice versa. These make sense because they are fixed routes. As far as automating them, it's a simple mapping. The vehicle doesn't have to make many decisions on where it has to go or what its destination is. And therefore, very similar to the example I've used a couple of times, the airport shuttle between terminals, you can run that with more people, with less staffing costs, and be able to expand that mobility for whatever campus area you're looking at. Circulators then kind of similar to the last one. Circulators, going around campus, airport. Again, they have a fixed route, and therefore they are a bit easier and earlier to be deployed. And so some examples that already have autonomous vehicle circulators: University of Michigan, there's a example down here that's, although that is an animation, Navia has actual vehicles running around Ann Arbor right now. Now with the pandemic going on, 2020 is a little strange, and a lot of these services have been suspended just due to not having the customers or the capacities of the vehicles are really reduced. So we'll kind of ignore the last 9-10 months right now, and as we all know, there's been impacts industry wide on how transportation is used. But down in Jacksonville, in Columbus, their service has been, instead of taking people, they're now using it for goods and medical supplies, and things moving around in Columbus, Ohio, until they are reauthorized to get people back on board. And in Treasure Island, Florida, in San Francisco. So these are just some of the examples of where automated vehicles are being used as circulators today. And then, of course, there's the not people side of it, automated goods movements. And if anyone's seen, and I would recommend, it's pretty awing, there's a number of videos out there of what Amazon warehouses and the new ones really look like today. And whatever you want to call them, robots, autonomous machinery, vehicles. There's not many people walking around on the floor these days, and there's a lot of automated movement of goods. That's now expanding out into port areas and things too, where you can see in this bottom picture where cargo and intermodal things going between a ship and a truck, or a ship and train, however that works at the port. Now those boxes can be moved around on these little transport vehicles without anyone in there, or without frankly having to have humans make the decision. The computer systems can logically move these around more efficiently than individual drivers. So you can have more efficient inventory handling, you need less space, and can, of course, be able to serve the increased demand that we all have with the things like the Amazon 2-day Prime delivery, as one example. Truck platooning, already mentioned, and so just here are some of the impacts. There's less wheel wander, and so that is an interesting challenge. If we did have all trucks driving together in the same exact wheel path, we all know that heavy vehicles are what really cause the degradation of our pavements and roadway. So there are some real other implications, and throughout the civil engineering world, into materials and pavement to consider when you do this. However, the efficiencies to be gained can certainly be offset by some of that. So there's one example there. Here's now example of when these technologies and some of these technologies are being tested and are being implemented in some fashion. Transitioning our highways, what we're starting to see around the country. You can see the example here on the I-95 corridor, or near the 95 corridor over on the East Coast, is adding in managed lanes, where you might see today an HOV lane. And I'm not sure for sure if Arizona has any high occupancy toll lanes, but then though you can take a high occupancy toll lane and transition it into, also allow electric vehicles on there, or have that as your managed connected vehicle lane. So that is how this kind of transition on our highways is happening. All right, connected vehicles. This is getting now back to the original question, and so, or the poll question that was at the beginning of the presentation. And it was somewhat of a trick question. So there is a lot of confusion, or a lot of activity that's been had in the last couple of years, but especially this past fall, with the Federal Communications Commission weighing in on the actual frequencies and technologies used for vehicle communications. So the poll question that was up is actually a trick question, because all four of the answers were correct. The 5.9 gigahertz spectrum is commonly referred to as the vehicle safety band, and the two different competing technologies that are being used on it are DSRC, dedicated short range communications, and C-V2X, connected, that's cellular vehicle to everything, is what C-V2X stands for. So the idea of a connected vehicle versus an autonomous vehicle sometimes can be a little confusing too. Of course, the ideal and the ultimately vehicles will be automated and connected, but autonomous vehicles and the purpose of the research and going into autonomy is to make the vehicle drivable essentially without a human. And so that is very much a function of the vehicle individually and how it's adapting and seeing the road and sensing around. Whereas a connected vehicle is all about a vehicle that is connected and communicating with other vehicles and the infrastructure around it. And by communicating, we mean sending, messages. Here I am. Here's my speed. I'm going to be approaching this signal this fast. Things of that nature. So ultimately, like I said, the future is that vehicles will be both automated and connected, but they actually are two kind of separate pathways. So regarding connectivity and connected vehicles, these are kind of the hot early areas where there are opportunities for connectivity. For those of you who are in ITS and CV and AV, you'll be very familiar with signal phase and timing, often called SPAT. And what that is that's where because if a vehicle is connected and can be receiving information from the traffic signal controller, it can lead to eco driving, where it can suggest a speed for you to be driving down the road, and essentially creating platoons in that green band, as well as things like transit signal priority or even freight priority. If a freight vehicle is connected in the signal and can tell it that it's at a particular approach and there's extra green time around, that can give the priority to freight, if that's what your corridor is designed to do. Some of the first and some of the flashiest applications, and what really is selling the connectivity, are our safety applications. And so from intersection collision avoidance to being able to either warn or actually actively brake at a back of a queue, pavement condition just monitoring, being able to get the information and develop IRI values and things, as well as warnings when there's a pothole or something ahead. Work zones can be essentially digitized and put into the vehicle. So your car, through connected vehicles and through that system, will be able to tell you, when and how far ahead of you the lane is closed. I think we've probably all run into where you see the construction sequence and signing up, and you're supposed to reduce speeds, but there's nothing going on. So if we are able to be more dynamic on those, especially moving work zones, and have the vehicles aware of where they are, have a much safer work zone without having to deploy all of those signs and everything. So clearly this is a ways off before we wouldn't have to do any of that, but this is where the opportunities for connectivity are coming up. And then of course in congestion reduction and payment solutions, there's once a large enough fleet of vehicles have connectivity to the infrastructure and roadside, then things like tolling can move beyond even license plate recognition or a transponder, and the vehicle itself can communicate, or you might be able to make some options. It might tell you, what the current toll is to get into the hot lane, and you can choose whether you do there within your vehicle. So the thing that's enabling connected vehicles, and most of us are probably on the infrastructure side as opposed to the automotive side, are these roadside units. And so this is what has kind of recently changed. So the current RSUs, roadside units, we're using this communications technology called DSRC that has been under development through kind of government research for going on 15 years, but really the last 10 years is when there's been pilot deployments and building upon that. Recently this fall, through various efforts and lobbying, the FCC looked at the spectrum and said, well, that's largely been unused for vehicle safety. There's still only pilots and tests going on in it, but things like the Wi-Fi industry and the cable industry really want more spectrum. So the FCC made a decision to essentially take some of that away, and also set their preference that a newer brand of communications called cellular vehicle to X should be what's used. Sorry, highlighting on screen, should be what's used within those frequency bands. And what that is, that does not necessarily mean that is does use 5G cellular networks, but it's not necessarily reliant on a 5G network. It is using essentially the same type of radio that would be in a 5G cell phone, is the type of radio that would be in a vehicle, and be able to use it for the vehicle safety things as well as other things like infotainment, which are of course becoming very popular in vehicles, to be connected just for a Wi-Fi hotspot or whatever kind of content you're getting in there for your kids in the back seat. So this is a really hot area right now, and with the change in administration within the FCC, change in federal administration, change in transportation secretary, it's very possible that we will see modifications or some backtracking on exactly what the government is promoting and is laying out there for vehicle safety. But that kind of goes to answer that question, and I did it as a trick question there because it is confusing. There are so many different things you can call it and different competing technologies right now that that's kind of one of the problems. There is no one thing to look at. This is just a quick diagram kind of showing that, you know, the vehicle to infrastructure platform and how that works. So won't spend much time there, but, you know, essentially it's showing the connected vehicle ecosystem requires both infrastructure and data and display, as well as the actual sensors on the vehicles, and traffic information is what kind of fuels the entire vehicle infrastructure platform. All right, so moving on to E of the ACEs, electric vehicles. So also huge opportunities for electrification. Big thing though is grid modernization and charging stations. Just if everyone were to go out and buy an electric vehicle, there absolutely would not be the capacity in most neighborhoods, nor the availability of charging stations once they're out on the road to accommodate that. So that's a huge area that all civil engineering is really involved in. And as that infrastructure piece is being worked out, there are also innovations in battery technologies, to make batteries lightweight or last longer. Wireless induction, which is being able to actually charge the battery while in motion, between wireless and dynamic induction. Electrified roadways would, allow somewhat, how this shows, the concept would be that you could have a lane that allowed inductive charging for your vehicle, and so it would essentially be maintaining its charge while in that lane. And then of course, portable chargers and looking at it. As far as kind of the trend here, you can see on this model, this is specifically looking at plug-in models available. In 2010, there was one plug-in model available. By next year, there are expected to be over 82 plug-in models available here in the U.S. Across all the different OEMs and brands. So it is near exponential growth in the vehicles and the popularity. However, getting to the infrastructure side, here's a graph where it shows major metropolitan areas that will face major infrastructure gaps that just aren't at a fundamental level ready for you can see out here, especially in Southern California, where a lot of electric vehicles are popular, there's just not enough infrastructure available. So I have a little plug in here for all of us. And like I mentioned, I know we're not all in transportation here, but the electrification in particular crosses all areas of civil engineering, between program management to develop roadmaps and policies and things with clients and how you deploy things, to the planning side of it, all the way to the site work and civil and electrical. So there's significant opportunities for everyone just in the electrification side of what we're seeing, how mobility is changing. And then the S, the last but not least, is shared mobility. Shared mobility is, can be described in different ways, but some of the main components right now and new trends are integrated payment solutions, things mobility as a service, mobility as a demand. I have an example of an application here from the Smart Columbus area, but there are a number, I don't want to name any particular one, but there are a number of apps now that you can get, and you plug in, I want to get from where I am to someplace else, to to an address, or to the museum, to the theater, and it will be able, and they can tell you multimodal how to plan the trip. You need to walk here, and then from here to here you can take this bus or this train, or you can take a bike, and be able to plan that whole trip, and then also getting to be able to integrate and pay for those trips. So that is a huge explosion in the idea of shared mobility, as well as then mobility hubs, taking kind of the traditional bus station approach, where maybe you would have, maybe the bus station also had some bike racks outside and there's a taxi stand. Well, now that is turning into a mobility hub where you can have a variety of your micromobility solutions, your scooters and bikes and things like that. You can transfer between, Uber, Lyft, and those other private entities, TNCs, and bus and rail. And so these kind of transfer stations are becoming mobility hubs, where then information and kiosks can be provided to get to your final destination. We also see a lot of new partnerships between service providers and areas and cities where non-traditionally we're working together, like the bike and scooter shares and things like that. That kind of came about with a vengeance, and almost seemed unregulated, or was in some areas, but where it has really thrived now, these cities and communities have ended up coming up with adopting policies and things to be able to incorporate those into their mobility ecosystem. This is just one example of mobility as a service, application. And so this is from Smart Columbus in particular. For those of you not as in tune, Smart Columbus is a huge project. It was a federal government funded grant award. They solicited, and cities all submitted to try to get the funding to become a smart city. So there are a number of cities, of course, now that are following the same type of path, but in Columbus in particular is one place we're working, and there one of the fundamental parts was this multimodal trip planning application. So as I've kind of already mentioned and described, it's integrated with all the different modes of services, and it's a one-stop shop where you can plan, book, and pay for your trip. And so, meaning with the app on your phone, I'll flip to it. So you can give it your accessibility preferences. If you do have a service dog or a caretaker with you, it'll make sure that when it plans your route, it takes that into accommodation. It will then show you. You can then tell it which options you are interested in. So, for instance, in this route, in this middle screen, you can see it has bike, bus, walking, but no scooters. And so the route that it's showed you, you can get to a bike that's docked here and get over here, and that's the bike segment. In this particular, you're going to the same place, but said, I don't want to ride a bike, but I'm okay with scooters. And it will give you the revised trip, realizing that the trip looks about and costs about the same here. But of course, those are aspects would update in real time if they were different costs. So all of this disruption, all of these ACEs creates opportunity. If you can see, I kind of use that term opportunity in many of the slides. So one of the interesting things, and this is getting back to my role as mentioned as an industry council lead, is HNTB as a consultancy. We have now formed partnerships and have NDAs with a variety of these companies out in the technology sector that are very much non-traditional partners, or subconsultants that we would use in any kind of traditional sense. So as you can see from the services here, this is we now have relationships and contacts with all of these various technology companies, and have them come in and bring webinars in monthly to our company, as well as we're able to connect our clients with the experts in the industry, since as consultants, we're not necessarily always always subject matter experts in any particular area. We can go out to the innovators that are directly working on these. So it's a new thing that we're doing, but that's not uncommon in the industry right now, is to be connecting very much outside of the traditional worlds that we are. So what does this all mean, and where are we going? So talked about a lot of cool things that are happening, that are about to happen. But ultimately, when all vehicles are automated and connected, it may be possible to eliminate infrastructure such as traffic signals and signs. This is a simulation developed by the University of Texas. Wouldn't want to be a pedestrian trying to cross here, but this shows how cooperatively vehicles that are all communicating with each other, as well as with the automated sense with the road, can literally operate without a traffic signal and navigate an intersection. If cars don't crash, then what does that mean? Of course, this is a very way far off scenario as far as every vehicle being autonomous out there, but it's what we need to start thinking about and planning for. More immediately, so what lies ahead? Are there going to be more vehicle miles traveled or less? Now, of course, like I said, we kind of have to ignore 2020. There's as far as vehicle miles traveled and mobility, it's a very odd year as far as looking at trends. But when we get back to a normal as far as vehicles and movement on the road, we have to plan for both. The possibility that there's going to be more vehicle miles traveled and less vehicle miles traveled. Maybe that's geographically different depending on where these systems apply. Do we need less parking? If vehicles are, for instance, shared vehicles are in use all day long, if you just like a bike share, if you were to get out of your apartment and take the share car, park it outside your office, and during the day somebody else picks up that same car and uses it because it's just a service, it's not something you own, do we need less parking? Maybe that helps us in the CBDs where parking is at a premium. Also presents big questions: private versus fleet ownership. In that exact example, well, you didn't own that car, you're able to schedule a service to use it for a particular time, but what does that mean for traditional purchasing and dealerships? Who owns the vehicles, or who should own the vehicles? Of course, impacts on transit, impacts on the climate, quality of life, and just what the urban area looks like. So lots of questions on what lies ahead. What we do know is what we do know are ACEs will help solve a lot. Vehicle automation will solve a lot of problems. It introduces other new ones. It will give us greater accessibility to opportunities. It certainly opens up more mobility choices, harmonized traffic flow, and greater traffic safety. So this is just the beginning. The future of mobility, then, I didn't even get into some of the really cool and crazy ideas that you see headlines about nowadays. Literal flying cars, Hyperloop networks, those are real things too. And those are the next generation of game-changing things in this ACES world. So it's the cycle of technologies and solutions for mobility is really been tightened up. Instead of there being several years of research and one little change made in, say, a pavement material, some of these technologies are changing by the month with updates. So it's a different way to look at it. So in summary, and before we can get into any questions and chat about this, these ACEs are a game changer. They also will require collaboration among all practice areas: urban and land use, transportation system design, planning, utilities, intermodal, environment, green space. All of that is impacted by these rapid changing aspects of mobility, and that's why we are all here together to discuss. So with that is the end of what I have prepared, and like I said, wanted to make sure I gave adequate time to go through and answer any questions or discuss any topics anyone has.
Wonderful. Thank you, Matthew. We did get a handful of questions, so I will read the question and then allow you to answer. Was there any consideration to urban air mobility in any of these type of studies, I guess?
That is a great question. And I think perhaps a little bias in the presentation because I'm not personally involved in too much of that, but urban air mobility is certainly an area that there are many innovations in. I mentioned that Uber had sold off their autonomous vehicle division. Uber still does actually though have and I can't think of the name of it right now, but it's for EVTOLs, electric vertical takeoff and landing vehicles. They have a flying car research they're doing. So it is, yes, in the aviation space, it is very real. And I don't know as much about that, but I'm very curious to see how that will fit in when some people might have the option of literally taking off and landing for personal mobility versus, right now, airplanes and aviation is very much more like a transit service where you have to have a hub and you have to have everybody gather in one space and take off. So it's almost opposite of what's happening in the transit world, where we might be able to have a more personal touch on aviation.
What would be the proper and safe way to pass a platoon of trucks?
That's a great question, and it's interesting. There is in many states, if not all states, actually a lot of times legislation or regulations on trucks traveling close together and sometimes they're called platoons or things like that. And that comes from a very kind of old safety thing of, oh, the drivers are going to run you off the road or something like that. So as far as the proper safe way to pass a platoon of trucks, in the platoons that I've seen, and I've got to ride in one, which was pretty cool. The platoons are typically 3 or 4 truck lengths or 3 or 4 trucks long, and they are using every type of sensor and autonomous technology out there. And so were actually cases where, because other drivers on the road didn't necessarily realize what was going on purpose, where somebody merged and got in between some of the vehicles. And so that is part of some of the research and technologies is being able to combine and distribute those platoons a little bit to allow for the dynamics on the road. Because I think it's unlikely that to consider that we would be able to run these platoons without having to break them up at some point or having to pass them. So it's a good question.
Yeah, I think that kind of touches a little bit on the next question, but if you have anything else to add to it, absolutely. Can cooperative driving be useful for truck platooning so that vehicles can communicate with other vehicles on the platoon to improve the road safety?
Absolutely. I think we'll see more truck platooning technologies on the road before we see a large penetration of other autonomous passenger vehicles on the road. But absolutely, cooperative driving is kind of the fundamental crux of that.
Right. Is there any consideration or how has confidentiality of the data in the safety message ensured to avoid hackers or eavesdropping using the data to launch any attacks or something like that?
Sure. So yeah, cybersecurity is and security really. It's I've heard some people recently say the word cyber is kind of we don't really need to say cybersecurity anymore. It's just security in general, security for everything. That's critical. One of the big fundamental things with the connected vehicle system is there is a security credentialing, it's SCMS, security credentialing monitoring system, and essentially. When the vehicles are talking to other vehicles are talking to the infrastructure, that sounds very simple, but essentially each entity on the system has a security certificate. It's a virtual type of thing, similar to how you digitally sign documents these days. In a lot of states accept digital signatures as long as you do it with a certain software or whatnot. So these digital security certificates is one of the aspects of security in that the vehicle needs to go through and be authenticated by the security system and back before it shares data or gets anything from the infrastructure. As far as anonymity and things like that, that's another aspect. All of the basic safety messages are designed so that the personal identifiable information about the vehicles, like the VIN number, is stripped out of that. Even though that's available to be pulled out of that system if you plug into that port on your car, the basic safety message strips that out and only provides the information that does not identify personal information about the vehicle, but just about the vehicle's location and trajectory as it's relevant to the application.
And then last question that I see in here is, can data transfer latency be a problem?
Absolutely, absolutely, and that's getting into the C-V2X versus DSRC in connected vehicles. That is why we haven't seen this really explode as quickly as we've seen autonomous vehicles explode. And by explode, I say from the first time you really heard about them to when you are seeing them on the road. Connected vehicle technologies have been in development for longer, and there's less of it out there right now. And that is a large aspect of it.
All right. We just got one more come in. How is the authentication into the network handled if there is a possibility of dynamic platooning of cars, and are those certificates the way to go?
That goes above my head and beyond me, but I'd be happy to send you some other resources within the USDOT where their research is happening. The idea of the security certificates is kind of the fundamental, what they've settled on for it. Getting back to that last question about latency and everything, I guess I didn't kind of fully answer that. So the 5G, and that's where frankly the FCC thought that by pushing us towards the cellular radio technology, which some of the fundamentals or principles of 5G technologies are very low latency, and so that's kind of we're on the crux of that. But the security credentialing certainly takes a chunk of that, and there are a lot of research projects right now. There are 3 main connected vehicle pilots around the country. There's one in Wyoming, one down with the THIA down in Florida at a tollway, and then one in New York City, DOT. And all 3 of them are kind of focused on slightly different aspects, right? That was a large competitive program too. Many cities and areas went after, we want to be a connected vehicle pilot. So in Wyoming, it's more the freeway and the more rural types of applications they're looking at. In Florida, it is they're working with the tollway and in mixed vehicle fleets. And in New York City, it's the downtown and the urban area. So between those 3 pilots is where a lot of the research and information, and they're working through as they add more and more vehicles into that, how to deal with with the real technical communication side of it.
Well, I think that is all the questions that I have on our end. I wanted to thank you again, Matthew, for giving us a presentation, and thank all of our participants here. Thank you so much for your time, and I will see you guys at the next virtual event. Thanks so much.
All right. Thank you for having me. Everyone have a good afternoon.
Have a good one, guys.